You all have heard about the carbon cycle, which is actually biogeochemical cycle by which carbon is exchanged between the biosphere, hydrosphere and atmosphere of the Earth. And one of the most important phenomenon is the striking of asteroid to the Earth. But what are the impacts of instability of carbon cycle and asteroid striking on Earth? You are watching Gateway to Knowledge, and today I am going to take you back in the history and will tell you how Earth was stressed before dinosaurs' extinction. According to a new study, recent evidences have give clues that our Earth was already experiencing instability in its carbon cycle before the asteroid impact that wiped out the dinosaurs. Let me tell you that asteroids are small, airless rocky worlds that revolve around the Sun and are too small to be called planets. They are also called space rocks, and they are 1 kilometer in diameter, strike Earth every 500,000 years on average. By measuring the chemistry of fossilized seashells collected in Antarctica, confirms that Earth was already unstable before the asteroid impact that wiped out the dinosaurs. It is said that dinosaurs got extinct by a Cretaceous-Paleogene mass extinction event. This is the first study to measure the calcium isotope composition of fossilized clam and snail shells. The researchers found that, in the run-up to the extinction event, the shell's chemistry shifted in response to a surge of carbon in the oceans. Let me tell you what are extinction events. An extinction event occurs when a large number of species die out in a relatively short period of time. Since life began on Earth, a number of major mass extinctions events have occurred, which have greatly exceeded the background extinction rate present at other times. As a result of these events, there is a sharp change in the diversity and abundance of multicellular organisms. There are two types of extinction events, mass and minor extinction events. Mass extinctions have sometimes accelerated the evolution of life on Earth. As a consequence of extinction events, a new dominant group is superior to the old group of organisms, and it results in the extinction of the old dominant group, and which makes way for the new one. The end Cretaceous mass extinction removed the non-avian dinosaurs and made it possible for mammals to expand into the large terrestrial vertebrate niches. This carbon intake was likely due to long-term eruptions from the Deccan Traps, a 200,000 square mile volcanic province located in modern India. During the years leading up to the asteroid impact, the Deccan Traps discharged massive amounts of carbon dioxide, CO2, into the atmosphere. The concentration of carbon dioxide acidified the oceans, directly affecting the organisms living there. This data suggested that the environment was changing before the asteroid impact, and these changes appear to correlate with the eruption of the Deccan Traps. The Earth was clearly under stress before the major mass extinction event. The asteroid impact coincides with pre-existing carbon cycle instability. But that doesn't mean that we cannot find the actual reason what caused the extinction. Previous studies have explored the potential effects of the Deccan Traps eruptions on the mass extinction event, but many have examined bulk sediments and used different chemical tracers. By focusing on a specific organism, the researchers gained a more precise, higher resolution record of the ocean's chemistry. Each shell is a snapshot. We know that shells grow quickly and change with water chemistry, because they live for such a short period of time. Each shell is a short, preserved snapshot of the ocean's chemistry. Seashells mostly are composed of calcium carbonate, the same mineral found in chalk, limestone and some antacid tablets. Carbon dioxide in water dissolves calcium carbonate. During the formation of the shells, CO2 likely affects shell composition even without dissolving them. To know that fossilized seashells show signs of global warming, the researchers examined shells collected from the Lopez de Bertodano Formation, a well-preserved, fossil-rich area on the west side of Seymour Island in Antarctica. They analyzed the shell's calcium isotope compositions using a state-of-the-art technique. The method involves dissolving shell samples to separate calcium from various other elements, followed by analysis with a mass spectrometer. The researchers said that they can measure calcium isotope variations with high precision, and those isotope variations are like fingerprints to help us understand what happened. Using this method, the team found surprising information. They expected to see some changes in the shell's composition, but they were surprised at how quickly the changes occurred. They were also surprised that they didn't see more changes associated with the extinction horizon itself. A future warning. The researchers said that understanding how the Earth responded to past extreme warming and CO2 input can help us prepare for how the planet will respond to current, human-caused climate change. To some degree, we think that ancient ocean acidification events are good analogues for what's happening now with anthropogenic carbon dioxide emissions. Perhaps we can use this work as a tool to better predict what might happen in the future. We can't ignore the rock record. The Earth system is sensitive to large and rapid additions of carbon dioxide. Current emissions will have environmental consequences. Thanks for watching and giving your precious time. Hope you enjoyed a short tutorial on how the seashells can be used to predict the sign of global warming. Until next time, keep smiling, spread happiness and stay blessed.